Okay, so when an ionic bond is forming, you're going to find something from the left side of the periodic table, you're going to have a metal, and then you're going to have something on the right-hand side of the periodic table, your non-metal. And recall that our group numbers, our groups have specific charges that they're going to form. Now, we're not going to talk about transition metals just yet, and we're also not going to talk about rare earth metals just yet. So group 1 is going to take on that +1, group 2 is +2, 13 is +3, 14 is ±4, 15 is -3, 16 is -2, 17 is -1, and we're not going to talk about noble gases for ionic bonding. So, when we are bonding, we're going to have a metal and a non-metal. We can have, for metals, we can have sodium, we can have potassium, we can have calcium, magnesium, a whole bunch of different ones. Non-metals, we could have chlorine, carbon, oxygen, nitrogen, fluorine, any of those good ones. And those are going to form these ionic bonds. So what you're going to want to do is look at the charges from the group number. So let's say sodium. Sodium is in group 1, which means it's going to take on a +1 charge. That's going to be the charge that it likes to take on to form its full octet. Chlorine is in group 17 and is going to take on a -1 charge naturally just to become stable to make its full outer shell. 1 sodium will have a +1 charge. 1 chlorine will have a -1 charge. These charges completely and perfectly balance each other out. So in order to create a bond between sodium and chlorine, you only need 1 sodium and 1 chlorine. And the way we write that is you do Na, and then you could put a 1 there, and then Cl, and there's a 1 there. But in these chemical formulas, we don't really write ones because in math, doing 1 times anything is pretty pointless. So we just write NaCl, and we just assume that the 1s are there. And that is our final product for the ionic bond. The number for the amount is always the number after, so that number after corresponds to the element before it. Now let's take a different scenario. Calcium. Calcium is in group 2, so it takes on a +2 charge. And let's take chlorine again for our nonmetal, and it takes on a -1 charge. We have 1 calcium that takes on a +2, 1 chlorine takes on a -1. Now, if I were to draw this, I have a plus and a plus. I have 2 pluses here, but over here I only have 1 minus. So these two balance out, but I'm left with 1 extra plus sign. What I do is I just add another chlorine into my equation, so I get another minus sign to balance out these charges. So I have 1 calcium, and I have 2 chlorines total. The way we would write that is we do Ca for the calcium, there's 1 of them, and then we do Cl, and we put a 2 after to tell us that there's 2 of those. Again, we do not have to write 1, so it's just CaCl2 for that ionic bond. Now there is a shortcut in order to do this, sort of, when doing these ionic bonds. So when we call that the crisscross method. So we take our calcium again, and it has that +2 charge. I have my chlorine, and it has its -1 charge. What they do for this crisscross method is we take this 2, we put it on the chlorine all the way down here, we take this 1, we put it on the calcium over here. The charges go away, we don't care about those, and we're left with Ca, 1 of them from the chlorine, that 1 crisscrossed onto the calcium, and this 2 crisscrosses onto the chlorine, and you get the same formula that we had gotten before, CaCl2, from that crisscross method. Let me show you another one. So let's do aluminum. Aluminum is a metal, and it has a +3 charge. And let's do oxygen. Oxygen is in group 16, it has a -2 charge. So with the crisscross method, we take this 3 from the aluminum and we put it on oxygen. We take this 2 from oxygen and we put it on aluminum. We do this crisscross motion and we get Al2, that 2 from the oxygen pushed onto aluminum, and we get oxygen, 3 of those. So there's 2 aluminums and 3 oxygens. So Al2O3 is our final result.